Bismillahirrahmanirrahim. Pressure. From the definition of the pressure, you can see that pressure is equal to force per unit area. If somebody asks you that define pressure, then pressure is equal to force per unit area. That how much force is being exerted on a unit area. Unit area mean the unit may be 1 centimeter square, maybe 1 meter square, or whatever the unit of the area you are taking. So we can consider that the pressure is basically is the force exerted per unit area. Symbolically, we will represent pressure with P, and pressure is equal to force over area, F for force and A for area. So remember this, that because pressure is the combination of force and area, force divided by area. So according to this, we have to make the unit. The unit of force is Newton, and the unit for area is meter square. So in the case of unit of pressure, remember this, Newton per meter square. Okay. We can also take Newton per centimeter square, but the standard unit for the pressure is Newton per meter square. And this Newton per meter square can also be called as pascals. Okay. So in the later definitions, we will discuss that what is Pascal and how the Pascal is 1 Newton per meter square. So if we are defining the Pascal, then Pascal is equal to 1 Newton per 1 meter square. So this is the definition, or you can say simply that what is Pascal. Now let us have an example. For example, if I am considering a box, this is a rectangular box which I am going to show you. Suppose this box has the weight is equal to 20 Newton. The dimensions of this box may be, say, this length of the box is 10 centimeter, say 10 centimeter, and this is 5 centimeter. And this height, say 2 centimeter. This is a solid box. Now we are discussing the pressure of the solids. Remember this, whenever we are talking about the pressure of the pressure of the solid exerts uh, on the base at which they are lying. Because here you will have to observe that what is the base of this solid. You will have to see the base. This base area will be considered. We are not going to consider the whole area of this box, this rectangular box, this cuboid. We are going to consider the base area only, because all of its force is being exerted on the base of this box. So how much force is being exerted? That force which this box is exerting on the surface at which it is lying, that is equal to force, is equal to weight. Whatever the weight is, this 20 Newton. So this box is exerting a 20 Newton force on this area. So if somebody asks you to find out the pressure, then the pressure is equal to force, which is 20 Newton, over area. Now the base area only at which this box is lying. So this area is equal to 10 into 5. Both the dimensions are given in centimeter. So this area will be centimeter square, because this under this box there is a rectangular surface. So this area is 50 centimeter square. So if you are writing that, please listen to me very carefully, because it is very important to understand this thing related to the unit. If I am writing that 20 over 50, which ultimately will be 2 over 5 Newton per centimeter square. So whatever the unit I am using, I will have to mention it for uh, pressure. But this Newton over centimeter square cannot be written as Pascal. We cannot write this as Pascal. To write this unit as Pascal, what we have to do, we have to take the uh, area in meter square. So you know that if we are taking the area in meter square, then what we have to do, we have to convert the centimeter square into meter square by dividing 2 times 100. So it will become meter square. So this is 0.02, 0.05 meter square. So it will be 0.05 meter square. Now observe it very carefully, that if I have converted this unit into meter square, so now the pressure can also be written like 20 over 0.05. Now you can simplify this also. In the simplified form, it will become 20 into 100. Now, whatever the way of simplification you can apply, it's up to you. So it is 400 Newton per meter square. So here you can see that in the case of centimeter square, I wrote 2 over 5 Newton per centimeter square. But if I have changed this area into meter square, so it is 400 Newton per meter square. Now we can write it as Pascal. This can be written as Pascals, which is represented by PA. Listen to me carefully. What we did here in this case, basically this is the solid block of 20 Newton weight. This block is exerting a pressure on the base of the block, because whenever the solids are exerting the pressure, you will have to see the base of that solid over which it is exerting the pressure. This is very important to understand, because further we have to see that how the pressure is directly or inversely proportional. For that, first of all, let me tell you some theoretical portion of the same. Here you can see that I have some notes which I'll inshallah upload today. You can see that here relationship between force, area, and pressure. You will have to understand this relationship. First of all, number one, force and pressure are directly proportional to each other. When I am using the word directly proportional, it means greater the force, greater will be the pressure. Remember this. Keeping the area in contact constant. Area in contact mean, for example, if I am talking about this block, then area in contact will be the area under this box. That will be, because this, if I'm putting this box on the table, then on the table, this area, which is 10 into 5 centimeters square, this area will touch the table. This area will be 10 into 5 centimeters square. That will be area in contact with the table over which this block will be lying. So remember this, we have to see that pressure is directly proportional. This pressure is directly proportional to the force exerted. Okay, number two, pressure and area are inversely proportional. Force and pressure are directly proportional, and pressure and area are inversely proportional to each other. This is very important to understand, that if we are increasing the area, then pressure will be decreased. They are inversely proportional to each other, provided force remains constant. You will have to consider this proviso also. You will have to see that what is kept constant. In the first case, we were keeping the area in contact constant. Now if the pressure and area are inversely proportional to each other, then you will have to keep the force as constant. Now let us understand this point also. For example, now let me give you the example of like, if you have uh, heel like this, this is a boot. Under this is a heel. You know that this boot which I am trying to make has the area under this boot, maybe suppose it is say 25 centimeters square, and there is a heel like this, a sandal, a lady's sandal like this, its heel. Suppose its area is 1 centimeter square. Now here you can see both of them have different areas. Now if these two shoes are worn by the same person, suppose that person has the weight equal to 500 Newton. 500 Newton. 500 Newton is the weight of the person who is wearing these two. Now you will have to see that how much force is being exerted under this. Okay, you will have to see that how much pressure is under this. Now if we are going to calculate the pressure under this heel, which is obviously a bigger heel as compared to this sandal heel, So here pressure is equal to force, which is 500 over area. This is 25 centimeter square. I'm going to convert this 25 centimeter square into meter square by dividing it. It is meter square. So we can write down like 0.0123425. So you can find out the pressure under this. In the same way, if I have this, I'm converting this into meter square. So this is like this, meter square, 0.0001 meter square. Now here, the pressure in this case, you will have to find out both the pressures. Here the pressure force 500 over the area 0.0001. Let's calculate. 1, 2, 3, 4. I'm doing the calculations without the use of the calculators. 25 ones are 25, 2s are 50, and 0. Now here pressure is 20. 1, 2, 3, 4. Newton per meter square. Now here the pressure. How much pressure? 5, 1, 2, 1, 2, 3, 4 Newton per meter square. Now you can see that the pressure in both the cases. If you are wearing this heel, that it is exerting a lesser pressure as compared to this one. Am I missing any zero? 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 25 twos are 50 and 0 in this way. Now you can consider that there is a great difference between these two pressures. Okay. Listen to me very carefully, that as I told you, that pressure is inversely proportional to the base area. If the base area is smaller, then there will be greater pressure. If the base area is larger, here in this case, the larger base area as compared to this, so there will be lesser pressure. Greater area, lesser pressure. Small area, greater pressure. So it is proof that pressure is inversely proportional to the base area. Okay. This was the second point which we were discussing. Now we are going to discuss the third point. The third point is written that force and area are directly proportional to each other, provided pressure remains constant. Force and area are directly proportional. Force and area are directly proportional to each other, provided pressure remains constant. Obviously, if you're not changing the pressure, then force and area will be directly proportional to each other. This is the force greater the uh, okay. Well, because you know that pressure is equal to force over area. So if you are not disturbing the pressure, then they will be directly to each other. Important to note that weight of a man is divided on if a man is standing on two legs. If you are standing on two legs, then your weight will be divided on each leg. So if the shoe has a wide area, they exert less pressure on soft snow, less likely to sink into the snow. Actually, this was the question that this is the question that if you are using the flat shoes on the snow, then it will be easier for you to walk on the snow, because if there will be a greater area, then there will be the lesser pressure, because area and pressure, we have discussed that pressure and area are inversely proportional to each other. Okay, now let us have some more examples. For example, you might have seen the thumb pin. The top of the thumb pin is flat and greater in area, but here under this thumb pin, if you are people are aware of this thumb pin which we use on the softboard, this is the tip of the thumb pin, which is used to insert on the softboard. The upper area is the greater area. Okay, this is the thumb pin with which we have to exert the force. On the top of this, we have to exert the force, and as a result, if this is sharp edge, then it can very easily be inserted into the board. In the same way, if you have a knife, you might have seen knives many times. You might have observed that if you are looking at the knife, then this edge of the knife is made very sharp, so that if this area under this edge is as much as lesser, then it will be easier for you to cut any object. Okay, so here in this way you can have many other examples where the by decreasing or increasing the area, we can change the pressure. And you know that if you are inserting a nail in the wall, if the um, nail of if the pointed edge of the nail is not so much pointed, then it will be difficult for you to ham to get this nail to be inserted in the wall. It will become very difficult for you. Okay, so you will have to see this the practical application now. For example, yeah, this example which I try to give you, you have a rectangular box like this. Say this is a rectangular box. uh, it is 5 meter, it is 1 meter, it is say 3 meters, and it is 1 meter. Now this matchbox is having, suppose, 500 Newton weight. This is the weight of the box. Now we will have to see that if it is lying like this in this orientation, how much pressure is being exerted. If I am placing it like this, that how much pressure will be exerted. So I am going to show you two orientation. This is the height, 5 meter. This is 1 meter, and this is 3 meter. This is the same box of 500 Newton weight. Here in the first case, situation A, the first situation, the first case, in this first case, you can find out the pressure. Pressure is equal to force 500 Newton over area. This area, 5 threes are 15. 15. So this will be 5 threes are 15 and 500. So here will be 100 over 3 Newton per meter square pressure. Now here in this case, the pressure is equal to force 500 Newton over the area, 3 ones are 3. So this will be 500 over 3 Newton per meter square. So here you can see the difference between these two. I hope that you can understand that here in the case, and this is the lesser pressure because more area is under this weight of 500 Newton. Here the lesser area is under this 500 Newton in the situation number 2. So from here you can find out the difference of pressures.